Good morning, children. Let us continue with yesterday's class. Question is, find all points of discontinuity of f where f is defined by these three conditions. Now, if you look here carefully, children, you can see here there are so many points around to discuss, right? One is at -3, one is at 3, one is for x less than -3, one is for x greater than -3, one is for x less than 3, one is for x greater than 3, right? And at -3 and 3 also. Okay, so let us check the definition properly. If you see here mod x, my first duty is to understand how this function is. Okay, so you know that modulus function is always positive. So what will happen? For x less than -3, your f of x will be defined as 3 minus x. Yes, only then it will be positive. For example, if it is -5, when it comes out, it will come as 5. So 5 plus 3 is 8. So it is equivalent to write as 3 minus of -5. That is also 8. Okay. Now for x, this is for x less than or equal to -3. Okay. Here. For x belonging to open interval -3 to 3, your function f of x is defined as -2x. Yeah. And for x greater than or equal to 3, your f of x is defined as 6x plus 2. Yes. So children, you can see that in this intervals, your function is continuous. Yes. You can check here, function is continuous at x less than or equal to -3, x between -3 to 3, also for x greater than or equal to 3. Why? Because your function is polynomial at these places, right? Your functions are polynomials, right? So that problem is solved. Now your problem is at x equal to -3, what happens? That means at the boundary, and also at x equal to 3, what happens? Yes, remaining all cases we have solved. So let's check the second definition. So it is limit as x tends to -3 from minus side of f of x. Okay, so what is that? -3, it is coming from your left side. So this definition, that means 3 minus x. So it is 3 minus x. So this is going to be, sorry, here I have to write here limit. Okay, limit as x tends to -3 minus. Okay, so it is going to be 3 minus of -3. 3 minus of -3, that is going to be 6. Okay. Now let us check what is limit as x tends to -3 plus of f of x. That means from your right side. So limit as x tends to -3 plus f of x. What is that? -3 plus this side. So it is -2x. So it is going to be -2 times -3, which is equal to 6. Same answer. Now we have to check what is the value of the function at -3. At -3, what is the function? Here, right? At -3. So it is going to be again 3 minus x, right? This is the definition. So it is going to be 3 minus of x means 3 minus of -3, which is again 6. So you can see here limit as x tends to -3 plus f of x, the same as limit as x tends to -3 minus f of x, same as f of -3. So your function is continuous at x equal to -3. Okay, so in this group one more point is added. Now we have to check at x equal to 3. So limit as x tends to 3 plus of f of x is what? What is it? 3 plus. 3 plus means this, no? Greater than 3. So it is 6x plus 2. 6x plus 2 means 6 3s are 18 plus 2 20. Now limit as x tends to 3 minus of f of x. So this is limit as x tends to 3 minus of f of x is less than 3. It is -2x. -2x means what, children? It is -6. Yeah. So here itself you can see that you no need to check what is that value at 3, because this here itself it is unequal. So there is no point in checking. Even if you check, no problem, because this condition is anyhow violated. So I can write f is not continuous at x equal to 3. So what is the point of discontinuity? So I can write here, therefore 3 is the point of discontinuity. Understood? Else everywhere this function is discontinuous. Okay. Now the next one. Next one also you have to find out the points of discontinuity. Okay, first let us rewrite this definition because it is modulus, right? So whenever modulus comes, first step is rewriting the definition. Okay, so you will have x less than 0, you will have x greater than 0, and you will have x equal to 0. At x equal to 0, no problem, it is already given. Now what will happen when x is less than 0, children? What will happen when your x is less than 0? Just think over it. So when x is less than 0, children, this will be modulus of x, no? That is minus of x, no? Yes, no? Otherwise it will become negative. So minus of x upon x will be minus 1. When x is positive, it is x, right? So x by x will be 1. Okay. So now I can see here, children, for x less than 0, for x greater than 0, and for x equal to 0. Sorry, for x less than 0, for x greater than 0, your function is constant. Yes, hence continuous. Right? Now our problem is at x equal to 0 because you can see that it is not directly approaching 0. It is approaching 0 from left and right also. So I have to check my second definition. So limit as x tends to 0 plus f of x is same as limit as x tends to 0 plus f of x is 1. So answer is 1. But limit as x tends to 0 minus of f of x is defined as limit as x tends to 0 minus of minus 1. That is minus 1. So I can see that limit as x tends to 0 minus f of x is not equal to limit as x tends to 0 plus of f of x. Therefore I can say f is discontinuous at x equal to 0, and 0 is called as point of discontinuity. I am writing in short, okay? You don't write like this. Alright, why this is minus 1, children? Because here if the answer has to be positive, it should come outside as minus of x. For example, if it is minus 3, when it comes out it is minus of minus 3. That means minus of x. So minus of x upon x is minus 1. Here it is x upon x is 1 and 0 it is already defined. Okay, next one. F of x is equal to x raised to 10 minus 1 for x less than or equal to 1, x square for x greater than 1. Now here also you can see that 1 is being approached from your left side and from your right side. So you need to check that definition. But before that, let us write for x less than 1 and for x greater than 1. What happens? Your function is polynomial function. Yes or no? Function is a polynomial function, and we have seen in the last class continuous. So hence f is continuous. Now our problem is at 1. Okay, so let's check at x equal to 1. So limit as x tends to 1 plus of f of x, you have to calculate. Limit as x tends to 1 minus of f of x, and then if they both are same, then you have to calculate f of 1. So limit as x tends to 1 plus. 1 plus means greater than 1. So it is x square. So it is 1. Similarly, limit as x tends to 1 minus is 1 minus means from your left side. So x raised to 10 minus 1. So it is 1 raised to 10 minus 1. 1 minus 1, which is 0. So no need of calculating f of 1 because here itself they are not same. So limit as x tends to 1 plus f of x not same as limit as x tends to 1 minus f of x. Therefore f is not continuous at x equal to 1, and therefore 1 is point of discontinuity. Okay. Now the next one. F of x is 2x, 0, 4x. X less than 0 here and 1. So here also you can see that there are 0 Point is 0, point is 1, x less than 0, x greater than 0, x less than 1, x greater than 0, x greater than 1. Okay, so let us write the known facts, whatever we can write. Okay, children, I can write for x less than 0, f is a polynomial. Yes. Hence, continuous. Yes. Now, for x between 0 and 1, f is constant. Hence, again, f is continuous. So, that problem is solved. Now, for x greater than 1, f is again polynomial. Yes. So, again, f is continuous. So, our problem is at 0 and at 1. So, let's check at 0. So, limit as x tends to 0 plus f of x is equal to limit as x tends to 0 plus, what is the f of x? 0 plus it is 0, right? Greater than 0. So, it is 0. So, answer is 0. Now, limit as x tends to 0 minus f of x is limit as x tends to 0 minus, what is that, less than 0, it is 2x. So 2x, so it is 2 into 0, 0. What is the value of the function at 0? Because they are same, we have checked. So it is again 0. So limit as x tends to 0 plus f of x, same as limit as x tends to 0 minus f of x, same as f of 0. So I can say f is continuous at x equal to 0. Now at x equal to 1, limit as x tends to 1 plus f of x is equal to limit as x tends to 1 plus, 1 plus means this, no? 4x. So it is 4 into 1, 4. Limit as x tends to 1 minus f of x is equal to limit as x tends to 1 minus 4x. 1 minus means less than. So it is 0. That is 0. So I can say limit as x tends to 1 plus f of x is not equal to limit as x tends to 1 minus f of x. It's not equal, right? Therefore, f is not continuous at x equal to 1. Therefore, 1 is the point where it is discontinuous, no children. It is called as point of discontinuity. Right? Nice problems they are to solve, right? You need not break your heads. You just apply the definition. You judge which definition to be used and accordingly you follow. That's all for today. Thank you, children.